The reason why we use power in maths, we include 2 square or 2 cube, is because it is a simplified way of writing a big number. Okay? If we have a number 2 square, 2 cube, it's easy to compute. 2 square is 4, 2 cube is 8. We know that. But what if we have something to the power of 56? We have something to the power of 102. The number is going to come out very big, right? So when we want to do our calculations, we don't want to have to write very, very big numbers. Of course, calculator can handle anything, but when we want to calculate it, actually by writing, this is a simplified way of doing that, okay? So there are some rules that we have to abide by when we use indices. Okay. Basically, whenever I say a to the power n, what I mean is it's actually a times a times a times n number of times, okay? N factors of a is basically what that is. Okay, now let's learn some terminology in indices. When I write 2 to the power 3, this part of the index notation is known as the base. So whenever I say base, I'm referring to that a value, okay? This value over here. And how about this guy? What's this guy known as? This is our power. Or what's another name for it? We will learn it this year. We can call this as index. Okay, so power or index. All right. So let's try some example. Okay, let's try some simple example. There's some examples over here. You can see in your notes as well. Don't just look here, guys. Please write. When you write, it will stick. Okay, make full use of the time when you come to class. Minus 2 to the power 3. What does it mean? Minus 2 multiplied by minus 2 multiplied by minus 2. What's the answer? Two times 2, 4. 4 times 2, 8. Negative 8. Okay. Now, take your calculator. Everybody take a calculator. Just type out minus 2 cube. Okay, like so. Minus 2 cube. Press equals. What do you get? Okay. How about minus 2 to the power of 4? Negative 16. The bracket is very, very important over here. Okay. See, let's try another example, okay? Negative 2 to the power of 4 equals to negative 2 times by negative 2 times by negative 2 times by negative 2. If you just put in the calculator, okay, you put this in the calculator, negative 2 power 4, you will get negative 16. Is this answer correct? Negative times negative. Negative times negative. We get negative times negative. Positive. Positive times negative. We get, okay, negative times negative again. We get. So isn't the answer supposed to be 16? There's no negative over here. How come when we put it in the calculator we're getting negative 16? All right, we didn't put the bracket. We have to make sure, we have to respect the bracket, okay, in the calculator. So if it's negative 2 power 4, you have to put negative 2 power 4. Then you will get 16. Okay, is that clear? We learned about it previously, right? Okay, we learned about negative and negative is positive, positive times negative is negative, and then positive, negative, and so on. But when the number becomes bigger, when it's 4, we can see, oh, there's a mistake here. I can easily see, okay, negative, negative, positive, and then positive plus negative should be negative again. I can easily see. But if the number becomes negative 2 to the power of 56, what are you going to do? Write it all down and then check one by one. Cannot, right? Always use your brackets. Okay, don't forget your bracket. All right. How about the next one? 2/4 to the power of, to the power of, alamak, it's not 2/4. 2/3 to the power of 4. Okay, same thing. 2/3 times by 2/3 times by 2/3 times by 2/3. I'm going to say it again. If you're not writing, you're missing out. You know why? Now's the time to write it in your mind. There's not a lot of time this year. All right, take every opportunity to do this. What is 2 times 2? 4. 4 times 2? 8 times 2? 16. 3 times 3? 9 times 3? 37 times 3? 81. Okay. Same, huh? Okay, next one. 0.3 to the power of 4. What are we doing? 0.3 times by 0.3 times by 0.3 times by 0.3. What's the answer? The answer comes out like some kind of exponent in the calculator. Okay, how do I change this to a normal decimal, a regular decimal? ABC. That changes it to a fraction. You're getting a fraction. Okay, Minghui is also getting a fraction. How if I want a decimal? 0.00 something. How do I get that? You see the mode, the one next to your on button? Press your mode. Press, press, press until you get norm. Got norm? Fixed sign norm? Press the norm, number 3. Okay, it's going to ask you norm 1 or 2. Click 2. You'll get your decimal answer. All right? So the answer is 0.0081. Okay? And of course, once you've done all this, make sure you clear it out again. Shift, clear, equals, equals. I have to see your calculator personally later. It's different. There's a norm somewhere there. All right. Okay, no problem. Okay. Expressing numbers with an index notation. Basically, we want to see inside a number got how many factors of a particular base, right? Okay, so let's say now we have 125. If I want to express this in index notation, can you imagine what the number should be? What should be the base? What should be the power? Can you imagine? It's too early for your imagination. You know why? Because you don't have a lot of practice doing this. What is 125 divided by 5? 25. What is 25 divided by 5? 5. What is 5 divided by 5? 1. All right. So we can conclude that 125 equals to 5 to the power 3. Now, when you get into the exercises, which you will see later on, you will see that there's a lot of questions whereby they want you to take a number like 125 and they want you to change it to an index notation. Okay, they want to come up with a base and also a power. This is something that you will familiarize only with practice. If I give you a number like 125, are you thinking, hey, is it 3 to the power 3? Is it 3 to the power 6? How do I know? How do I know what should be index notation? The more exercises you do, the more you will know. Okay, that. Now we learned that 3 to the power 4 is 81. We learned that today, isn't it? Yeah. So next time you see the number 81, you know that it's not only 9 to the power 2, it's also 3 to the power 4, right? There's more than one type of index notation that we can come out of 81. Okay, so this will be useful when you're solving the problems later. Okay, let's look at this. 5x equals to 625. Again, 625 means nothing to you right now. Hopefully, as we keep doing exercises, you will easily be able to remember that 625 is actually 5 to the power 4. All right, so if I ask you what is x in this situation, x is 4, correct? X is going to be 4. So a lot of the questions will do this. They'll give you a number, you figure out what should be the index notation of that, how to write it as an index number. Okay, let's check out the laws of indices.
So, teacher, if we want to know, like, for example, like you, a question will ask, like, what's the index notation of 64? Then we can use the calculator, use square, or use the.
You can
Square root and zero.
square root, cube root, quadratic root, but you have to know what root you want to take, right? If it's square, like 3 square equals to 9. If you take the square root of 9, then you'll get 3. But what if it's not a square root? What if it's a cube root? Like 3 times 3 times 3. The cube root of 27 is 3, for instance. So as the number gets bigger, it gets a bit more challenging. We can do a bit of trial and error in the calculator when you're not sure. For example, just now, you're not sure, 125, what should I do? What should be the base? We try 4 lah, okay? 4 times 4, 16. No. 16 times 4, 64. No. Times 4 again, 256. Already overshoot 125. So we know that 4 is not the base in this case. So we can try 5. But we don't want to waste time doing this during exam, right? So we want to familiarize. 125 is most likely linked to 5. 5 to the power of something. It was 5 to the power of something, but what? Okay, I check like that. All right. Okay. Now let's look at some of the laws of indices. Basically, it's some of the rules that we have to play if we want to use indices in our calculation. Indices can help to ease your calculation, but you have to follow the rule. If you don't follow, basically, you're going to get the wrong answer lah. All right. The first one. A to the power m times by a to the power n equals to a to the power m plus n. Okay. This is one of the laws that you need to know. Right. Now let's see this in action, okay? 5 to the power 2 times by 5 to the power of 4. What does this look like? 5 times 5 times by 5 times 5 times 5 times 5. What is this? Let's say I remove the brackets. How many 5s do I have? 4, 5, and 6, which we can simplify this into 5 to the power of 6. So can we see? When we have these two, the base is the same, 5 and 5, we can basically just add the power. All right? Only if the base is the same, right? Okay. Now let's see the next one, the example that's given over there. How do we deal with this situation? 2 to the power of 3 times by 5 times by 2 to the power of 2 times by 5 to the power of 2. we don't have the same base anymore. Some of them the base is 2, some of them the base is 5. So in this case, we have to group them up. Okay, let's put the 2's together first. 2 to the power of 3 times by 2 to the power of 2 times by 5 to the power of, there's no power, which means it's actually 1 lah. Okay, times by 5 to the power of 2. So what do we do now? The base is the same. So what can we do with the power? We can add them. 2 to the power of 3 plus 2 times by 5 to the power of 1 plus 2. So we get 2 to the power of 5 and 5 to the power of 3. Okay. Multiplication becomes plus, basically.